Have you ever stopped to think about what happens when you turn on the tap? I mean, really think about it. It's this incredible complex journey that's happening 24/7, mostly out of sight. Today, we're going to pull back the curtain on one of the greatest and most invisible miracles of modern life. Okay, let's get into it.
Just get your head around that number for a second. 300 million gallons. That is an insane amount of water. It's enough to fill almost 450 Olympic-sized swimming pools. And that's what just one large treatment plant can clean in a single day. It's this absolutely massive feat of engineering that keeps the water safe for millions of us. The scale is just wow. All right, so here's how we're going to break it all down. First, we'll talk about the invisible miracle itself. Then we'll run through what I like to call the cleaning gauntlet, the traditional way we purify water. Next up, we'll look at why that system is now a system under pressure. And finally, we'll get into the really cool stuff, the future, which is the smart water grid. You know, for basically all of human history, just finding clean water was a life-or-death struggle. So the fact that we can deliver safe, drinkable water on demand to millions of people, it's genuinely one of the biggest public health victories ever. It's something we totally take for granted, but it's this constant, complicated fight to make it happen. And this right here really captures the whole transformation. You start with this raw, murky water from a river or a lake full of dirt, bacteria, you name it. And then, through this brilliant process, it becomes the clear, safe water we drink every day. So how on earth do they do that? Let's get into the nitty-gritty. For decades, cities have been using this time-tested, multi-stage process to get the job done. I want you to think of it like a tough obstacle course, a gauntlet that the water has to survive, getting cleaner and safer at every single station. And here are the 4 key stages. First up is coagulation. This is where they add special chemicals that basically act like glue, making all the tiny bits of dirt stick together. Next is sedimentation. All those new heavy clumps, they're called floc, are left to just sink to the bottom. Simple. Then comes filtration, where the water is pushed through layers of sand and charcoal to catch anything even smaller. And for the final knockout blow, disinfection. A little bit of chlorine is added to kill off any nasty bacteria or viruses that might be left. So that term we just mentioned, flocculation, that's the real secret sauce here. Without it, those little dirt particles are way too small and light to get out of the water. By making them clumped together into this flock, we can just let gravity do all the hard work for us. It's such a simple but brilliant piece of science. Okay, so we've got this incredible system, right? It's worked for 100 years, it's saved millions of lives. You'd think the problem is solved. We can just sit back and relax. But, well, is that really the whole story? Yeah, as the slide asks, is it perfect? The answer is not quite. See, the treatment plant itself is a work of genius, no doubt, but it's only one piece of the puzzle. The really tough challenges today actually start after the water is sparkling clean. And here's where the pressure comes from. A lot of our cities are dealing with pipes that are ancient, leading to leaks and a massive problem called non-revenue water, or NRW. This is perfectly clean, treated water that just leaks into the ground before it ever gets to a customer. In some places, that's over 30% of the entire supply, just gone. Add to that, a lot of the monitoring is slow and manual, and of course, our cities just keep growing. The old system is really starting to feel the strain. But this is where it gets really, really interesting. To solve these 21st century problems, we're turning to 21st century tech. We're right on the edge of a huge upgrade for our water systems, creating something called a smart water grid. And the engine behind this whole evolution is the Internet of Things, or IoT. Just imagine a huge web of smart sensors and field instruments hidden all throughout the water network, from the plant inside the pipes all the way to your neighborhood. These things are like the eyes and ears of the grid, constantly monitoring pressure, flow, and water quality in real time, all day, every day. And look, this isn't some far-off theory. It's actually happening right now. Let's take a look at Malaysia. They're making this huge digital leap, putting these smart technologies to work across their national water system. They're using it to tackle that massive non-revenue water problem head-on. And this slide just lays out the night and day difference. The old way is all reactive. You find a problem after it's already a big deal, right? You find out a pipe is broken because a street is flooding. But the IoT approach is predictive. A sensor can detect a tiny pressure drop, flag it as a potential leak, and send a crew to fix it before you or I ever even notice. It's a total game changer.
So, what do you get from all this real-time data? Well, the benefits are huge. Water authorities can slash the amount of water being lost, which saves a vital resource and a lot of money. They can find and fix leaks in hours instead of weeks, and they can guarantee the water quality stays perfect all the way from the plant to your tap.
And in the end, this is why it all matters so much. A smart water grid isn't just about throwing fancy gadgets at a problem. It's about building a water system that's tougher, way less wasteful, and fundamentally safer for every single one of us. It's about making sure one of our most precious resources is protected for the future.
So we'll leave you with this thought to chew on. We've just made our water intelligent. So, what's next? The power grid? How we handle our trash, our transportation networks? The same ideas of sensing, monitoring, and predicting could completely transform all the other invisible systems that make our cities work. The invisible miracle of water is really just the beginning.